Hello friends, in this video we'll see limit of sequences of real numbers. Let's see definition of limit of sequence. Let xn be a sequence of real numbers a real number L is said to be a limit of the sequence of real number xn if for any given epsilon greater than 0 there exists a natural number n naught such that the mod of xn minus L is less than epsilon for all n greater equal n naught. It means for any given epsilon greater than 0, there must be at least one natural number n naught such that the difference between xn and L is less than epsilon, means mod of xn minus L less than epsilon for all n greater equal n naught. Then we have to say L is a limit of a sequence xn. It is also denoted by limit n tends to infinity of xn is equal to L, or xn tends to L as n tends to infinity. Means if n tends to infinity, means if value of n increasing, then the terms of the sequences tends to L. Then L is said to be a limit of sequence xn. Let's see the examples. We know that limit n tends to infinity of 1 by n is equal to 0. That means 0 is the limit of sequence of real numbers 1 by n. It means 1 by n tends to 0 as n tends to infinity. Let's prove it. Let epsilon greater than 0 be any given real number. See, to prove this, we have to find a natural number n naught such that mod of 1 by n minus 0 is less than epsilon for all n greater equal that n naught. We have to find such a natural number n naught. Okay. Consider 1 by n minus 0. Sorry, mod of 1 by n minus 0. See, mod of 1 by n minus 0 is same as mod of 1 by n, and since 1 by n is positive, mod of 1 by n is 1 by n, and it is true for all natural number n. Therefore, if mod of 1 by n minus 0 is less than epsilon, equivalent to 1 by n less than epsilon, and that is equivalent to n greater than epsilon. This is also true for all natural numbers n. By Archimedean property, for 1 by epsilon greater than 0, there exists a natural number n naught such that n naught is greater than 1 by epsilon. Archimedean property says that there always exists a natural number greater than for any given real number. Since epsilon is positive, 1 by epsilon is also positive real number, and by Archimedean property we can get a natural number n naught such that n naught is greater than 1 by epsilon. Therefore, for n greater equal n naught, for n greater equal n naught, we can have n greater than 1 by epsilon, because we have we are taking n greater equal n naught, and n naught is greater than 1 by epsilon. So for n greater equal n naught, n is greater than 1 by epsilon. Therefore, we can say that for n greater equal n naught, we have here must be n greater than 1 by epsilon. So for n greater than 1 by epsilon, mod of 1 by n minus 0 is less than epsilon. Mod of 1 by n minus 0 is less than epsilon. That means we got for any given epsilon greater than 0, we have a natural number n naught. There exists a natural number n naught such that mod of 1 by n minus 0 is less than epsilon for all n greater equal n naught. Means we proved that 0 is the limit of the sequence of real numbers 1 by n, and that means limit n tends to infinity of 1 by n is equal to 0. Let's see another example. We also know that limit n tends to infinity of n upon n plus 1 is equal to 1. That means 1 is the limit of sequences of real numbers n upon n plus 1. That means n upon n plus 1 tends to 1 as n tends to infinity. Let's prove it. Let epsilon greater than 0 be any given real number. To prove this, we have to find a natural number n node such that mod of n upon n plus 1 minus 1 is less than epsilon for all n greater or equal n node. Consider mod of n upon n plus 1 minus 1. See, it is equal to mod of n minus n plus 1 by n plus 1, and that is equal to mod of n minus n minus 1 by n plus 1, and this is equal to minus 1 upon n plus 1, and this is equal to 1 upon n plus 1. But mod of n plus 1 is less than 1 by n, therefore we can say that mod of n upon n plus 1 minus 1 is less than 1 by n, and this is true for any natural number n. So we have epsilon is positive real number, therefore 1 by epsilon is also a positive real number, and by Archimedean property there exists a natural number n node such that n node is greater than 1 by epsilon. Therefore, for n greater or equal n node, we have n is greater than 1 by epsilon. Similarly, we have seen this earlier. Here we have n greater or equal n node, and n node is greater than 1 by epsilon. So for n greater or equal n node, n is greater than 1 by epsilon. Therefore, for n greater or equal n node, 1 by n is less than epsilon, and therefore for n greater or equal n node, we have mod of n upon n plus 1 minus 1 is strictly less than 1 by n, and for n greater or equal n node, 1 by n is less than epsilon. So for n greater or equal n node, mod of n upon n plus 1 minus 1 is less than epsilon. Means we proved that for any given epsilon greater than 0, there exists a natural number n node. There exists this natural number n node such that mod of n upon n plus 1 minus 1 is less than epsilon for all n greater or equal n node. It means we proved that one is the limit of sequence of real numbers n upon n plus 1. That means we prove that limit n tends to infinity of n upon n plus 1 is equal to 1. Okay. In the next video, we'll see what is meant by convergence sequence of real numbers and divergence sequence of real numbers. Okay. Thank you for watching the video.